15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on yet another edition of the Stark Raving Mad podcast they call Space Nuts. It's also the title of a book that some bloke wrote. I'm just trying to think of his name. Could have been Professor Fred Watson. Hello.
Well, it's kind of you to remember. Sometimes I can't remember who I am myself. So it's very good that you are doing. Yes.
How are you, sir?
I'm welcome. Very well, thank you. I've been of rude health since we last spoke, and hope to continue that way until we next speak.
It seems like only yesterday since we spoke.
It does, doesn't it? Isn't that astonishing? It seems
Actually,
like...
I'm sitting here feeling incredibly dejected because the forecast for today in our terribly drought-stricken part of Australia, we haven't had fires because there's nothing left to burn, but 95% chance of rain today, and it is getting into late afternoon, and it is still sunny.
Okay, so
I am down in the dumps. I've been busting for this rain.
I'm going to cheer you up, Andrew, because I can see on the radar, which apparently you can't, but I can, that by the time we finish speaking, it'll probably be raining.
All right, I'm going to keep my eye out the window.
Hold me to that. Yes,
we will see in real time whether or not that happens.
Yeah. It could just fizzle out, as you say. It could just say, "Oh, there's nothing left."
Unfortunately, the pattern over the last year or two has been, 4 or 5 days out. 20%, 90% chance of rain. Then it goes 70. Then it goes 40. Then it goes 10, and then there's nothing. So I hope it comes. We desperately need it.
Yes.
Now, today we're going to be talking about a couple of bizarre objects that have been found at the centre of our galaxy. These are weird, but they may have an idea as to what they are. There's also this interesting theory. We've talked in the past about how life may or may not have evolved or popped up on other parts, in other planets or moons or whatever, assuming it's there, because we haven't found it yet. But there's been a reverse theory that maybe Earth is seeding other worlds rather than someone seeding us. That really is an interesting discussion to have, and we're going to have it. We've allocated 90 seconds to it, so we'll get to that soon. Also, a question from Ashley: what remains after a Type 1a supernova? Ashley, I'm reckoning there's ash, so you would survive. And a question about Hawking radiation. So we'll get into all of that on this episode, number 186 of the Space Nuts podcast. First, Fred, these, and not my words, the words of eminent scientists, bizarre objects at the centre of our galaxy. Could be shopping trolleys, but I'm thinking maybe something else. Because that's where they go. That's where them and pens.
Yes, they of course in Dubbo they last eternally because there's never any rain to make them rusty. So
actually, they all end up in the bottom of the river. I'm sure of it.
You mean you've still got a river?
Well, because we've got weirs, there's the illusion of water.
The illusion of water. Okay, so from lunacy to the galactic centre, this is some work. It's kind of ongoing work that really dates back, or its origins date back 20 years, and it's stuff that I find very exciting, as I think most astronomers do, and that is to do with the objects which are in orbit around the black hole at the centre of our galaxy. And in fact, it's because of objects like this that we know that the object in the middle of our galaxy is a black hole. There's a number of stars which have been monitored principally by two groups, one in the United States and one in Germany, or based in Germany. Those two sets of collaborations basically use big telescopes actually in Hawaii and in Chile to penetrate the dust that lies between ourselves and the center of our galaxy and look at the motions of stars. And you can do that with a technique called interferometry, if you look over a period of many years, you can actually see these stars moving in orbits around the galactic center, and that is fabulous stuff. It's, as I said, the fact that you can measure how these stars move, give you the mass of the object at the center, and it has to be a black hole. However, one of those two groups, in fact, the group based, excuse me, at University of California in Los Angeles, they have been discovering some rather mysterious objects. This is a group led by an astronomer by the name of Andrea Gates. She's very well known in this field. She's been working on it for many years. And what they have uncovered is things that basically look like stars for some of the time, but look like clouds of gas for the rest of the time.
That is bizarre. You've got to wonder how that might happen. I'm thinking gravitational effect.
Well, I think that's right, but there is more to it than just gravitation. But I think you're absolutely right that the intense gravitational field around the black hole actually makes objects that anywhere else in the galaxy would look perfectly normal, but turns them into things that are very peculiar. Plus the fact you've got to bear in mind, of course, that we're looking 25,000 light years basically through a tunnel in dust clouds, and so the information we've got is not. It's in a sense you've got to analyze the way the light is presented to you, the way it interferes with itself to give you a kind of idea of what's going on in the middle. It's not like just taking a direct image and saying, here's a nice picture of the galactic center. It's kind of more like what was done when the black hole was imaged last year, when the black hole around the galaxy, in the center of the galaxy M87 was imaged. So just backtracking from that and cutting to the chase, let me just read, I think, from the press release that they issued. The new objects look compact most of the time and stretch out when their orbits bring them closest to the black hole. And their orbits range from about 100 to 1,000 years. Now, by that, they mean the time it takes them to go once around the black hole. So these things are a little bit further out than the stars that we've observed, because one of those stars, if I remember rightly, has an orbital period of 17 years, and that brings it very close to the black hole. But it behaves like a normal star. These things are further away, and they behave like something else.
That is weird.
It is strange, yeah. So once again, reading from the press release, the research group identified an unusual object at the center of our galaxy in 2005, which was later named G1. And I think G was for gas because they thought it was a gas cloud. And then the group in Germany, which I mentioned earlier, they found something that they called G2. And, both of them thought these were gas clouds. But the research team led by Andrea Gates think now that G2 is probably two stars that had been orbiting the black hole one after the other, kind of in tandem, but then had merged into a very large star as they got closer to the black hole. And that's where the gravitational influence comes in. So Andrea Gates says, at the time of closest approach, G2 had a really strange signature. We had seen it before, but it didn't look too peculiar until it got close to the black hole and became elongated and much of its gas torn apart. It went from being a pretty innocuous object when it was far from the black hole to one that was really stretched out and distorted at its closest approach. And it lost its outer shell, and now it's getting more compact again. Actually, another of the authors to this paper says one of the things that has gotten everybody excited about the G objects is that the stuff that gets pulled off them by the tidal forces as they sweep by the central black hole must inevitably fall into the black hole. And when that happens, it might be able to produce an impressive fireworks show, since the material eaten by the black hole will heat up and emit copious radiation before it disappears across the event horizon. That's Mark Morris, who's another UCLA professor of physics and astronomy. So really interesting. You know, so you've got two objects here that behave in a very peculiar way. And the question is, are they just complete, you know, basket cases, or are they common? And the research group led by Andrea Gates has answered that question by discovering 4 more objects, which, by the way, are called G3, G4, G5, and G6, that have the similar characteristics.
And they're obviously around the same black hole. So there's
yes, that's right. Yeah, so they're in different orbits around the same black hole. And basically the bottom line in all this is that the group in UCLA believe that all these 6 objects were binary stars, that's to say 2 stars orbiting around a common centre of gravity, but have merged because they find themselves in such a weird gravitational field where the supermassive black hole is. And so that sounds as though that's a likely explanation, that what we're seeing is peculiar merging phenomena that are happening almost before our eyes because of the intense gravitational field that these binary stars are actually being subjected to.
What is the likely fate of these supposed stars? Are they, you know, destined to be destroyed?
Probably not. Actually, it's it sounds a bit bizarre that things orbiting in this intense gravitational field, and it's so intense that it disrupts the motion of binary stars. It's odd that the odds are that what's left of these merged binary stars, when they merge together to form, rather than 6 pairs of objects, 6 separate objects, they will just continue orbiting the black hole without too much disruption, as is happening to the stars which are much closer in. Their orbits are stable, and it's only when you've got something disrupted, like maybe the envelope of gas torn off what used to be 2 stars but is now 1, if that has a velocity that allows it to plummet in towards the black hole, then it'll be gobbled up, as that comment from Mark Morris mentioned.
Okay, so obviously they're going to keep looking at this and try and learn as much as they can. And as you say, it's a difficult thing to see because of, the dirt. We live in a filthy environment, really. But very hard.
That's Dubbo. That's right.
Yes, yeah. Very hard to see through all that stuff.
Yeah, no, that's right. It's Andrea Gates makes the comment, which I think is an interesting one, that this vicinity of our galaxy, the area around the centre, has a density of stars 1 billion times higher than in our part of the galaxy, and so everything's different. You know, the gravitational field is different, the density of objects is different, the magnetic fields are more extreme, and there's kind of, X-ray radiation bursting out of the black hole, there's accretion disk. It's a very different environment from where we hang out in the galaxy. And hopefully that will give us a sort of laboratory with such different conditions that we can observe phenomena that take place there that wouldn't happen in our neck of the woods.
Okay. Probably a lot more to learn, perhaps when they get some bigger and better telescopes out there, we might be able to look at stuff like that. Who knows? Yeah,
that's right. The coming generation of ELTs, extremely large telescopes, will give us actually an even better view of these objects around the centre of the galaxy. And so in a decade or so, when you and I are completely in our dotage, we might be talking about this stuff with a little bit more insight than we can at the moment.
Okay. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, don't forget, if you're a YouTuber, or if you play the tuba, you can jump onto our YouTube page and subscribe. We're trying to reach 1,000 subscribers, and since we last spoke, Fred, we've increased the number by 1.
Ta-da!
We're going well. Yes, you can listen to all our back episodes on YouTube as easily as hitting play. In fact, you can hit play all and listen to all 186 non-stop. And actually, Fred, I got some emails over the holiday break from people who said that they started again listening to our podcast from the very beginning, which I think is wonderful. That's very nice.
I think it is too. I'm totally flattered that anybody should want to listen to us at all, let alone twice.
Yes, well, good for them. I think, I'm pleased with the support. So youtube.com/C for Charlie /Space Nuts. You'll find us on YouTube. And if you want to subscribe there, please do, and see if we can get up to the magic 1,000. Now, Fred, we are going to talk about a topic of great interest, of much speculation, and that is the movement of life throughout the solar system and the galaxy. Maybe the universe. We're probably getting a bit stretchy there, but we've always thought, or there's been theories, that life came about on Earth as the result of something seeding the planet. But what if it's the other way around? Life started here and we are seeding everywhere else. Wouldn't that be a turn up for the books?
It would indeed. And the person who's put that forward was not in the least surprised to see his name attached to this paper. Harvard University astronomer Avi Loeb, he's the director of the Harvard Center for Astrophysics, with his colleague Amir Siraj. They have put forward a paper that draws attention to the possibility that exactly what you've described might have happened, that living organisms on the Earth may have been picked up by passing interstellar asteroids, and we now know that these things exist because we've had visits from them.
The space doogie.
Yeah, that's right. Picked up by things like that and carried to other solar systems, or as you say, even beyond the realms of the galaxy. So the story really goes back to the 1970s, when Fred Hoyle, a very great British astronomer, sadly no longer with us, and Chandra Wickramasinghe, who was one of I think he was one of Fred's PhD students, now, but I believe at the University of Buckingham. He spent a long time at the University of Cardiff, but he's now in Buckingham. And I actually, many years ago in my career, I heard Fred Hoyle speaking about this really interesting talk. They proposed the idea that the reason why we have life on Earth is that, exactly as you said, that it was seeded from space. So microbes actually arriving some means or another, perhaps by meteorites and things of that sort. And we talked recently about the Murchison meteorite, which is full of organic material. So the Hoyle and Wickramasinghe suggestion was that perhaps that sort of organic material was what gave rise to life on Earth. And actually, this topic, there was a very prominent and really expansive paper came out on this last year that elaborated on this possibility, and it talked about there is something, I think it's called, if I'm remembering rightly, the Precambrian explosion. Have I got the term right? Let me just have a look at that, because that's a key part of it. That there was this sudden explosion of diversity back in the Earth's early history. Sorry, it wasn't the Precambrian, it was the Cambrian explosion. And I'm just trying to get a date for that. It was, basically in geological time. It may even have been very old, perhaps, 3 billion years ago. I need to look that up. Anyway, the Cambrian explosion was suggested by Chandra Wickramasinghe, because I think this suggestion was made after Fred's death. But the idea was that this explosion of life was caused by stuff coming from outer space. In other words, it wasn't just a result of life rapidly evolving on Earth. that stuff came from outer space, and we got this huge, huge level of diversity on Earth.
They're suggesting the time frame between 541 and 530 million years ago.
Yes, that's right. That rings an absolute bell. It's something like that, of order 500 million years. Yeah. So that's put in a framework of the idea that we on Earth received living organisms from outer space. But this turns it on its head and says, well, yes, that might have happened, but the opposite could have happened as well. And so what Amir Siraj and Avi Loeb have done is they have looked at basically modeled the possibility that microbes in the atmosphere of the Earth could have been transferred to anything like a comet or an asteroid passing through from another solar system that had a close encounter with the Earth. We know, for example, that there are, colonies of microbes in the atmosphere as high as 77 kilometers from the surface. Now, that's not very far from the edge of space at 100 kilometers away. So, and we know already that microbes exist, can survive on the outside of the International Space Station. You and I have talked about that many times. The idea that microbes could exist in the upper atmosphere and perhaps, be transferred to a passing object. They've modeled this possibility, and sure enough, they say at certain speeds and particular angles, both comets and asteroids could actually graze the upper atmosphere and collect stuff. And it may well be that the Earth has spread microbial life throughout the solar system and beyond. The
smoking gun will be us discovering microbial life elsewhere and discovering that it is of the same making.
Yeah, exactly. That's right.
That won't suggest absolutely that it came from here, but it will suggest that it did come from the same source, wherever that may be.
Wherever it was, that's right. So if we find, if we get to DNA sequence things on Mars and find that they've got the same genetic ancestry as life on Earth has, you don't really know whether this stuff's come from Mars or this stuff's come from Earth. But what you do know, as you've just said, is that it has a common source. It's a really interesting piece of work.
We had a near miss, I will call it, some years ago, I think during the Clinton administration, where they found a rock and it had fossilised microbes on it, as far as I remember, and they initially thought it came from Mars.
Yes, that's right. Well, it does come from Mars. That's the ALH
microbes.
84001, I think it's called, meteorite. So it's definitely come from Mars. But the dispute is not whether it comes from Mars; it's whether the features that the microscopic features that were found on it actually have a biological origin. And the consensus among scientists is that they're actually chemical rather than biological. Many times we've been warned against seeing things that look like living organisms or fossilized living organisms and actually saying, well, they look like it, so that must be what it is. I think you and I spoke last year about
Ethiopia.
That's right. Yes, that's the exactly that. That some things that were found in the lake in Ethiopia have a chemical origin, in fact, I think I mentioned during that conversation I've been talking to an astrobiologist, formerly in the United States but now in Italy, who sent me a reference to a book published in, I think it was 1914. It was the early part of the 20th century, which is full of pictures of chemical gardens, things that are pure chemistry but look for all the world like living plants. Really interesting stuff. And so you just can't say, well, it looks like it, therefore it is it. There has to be much more to it than that. Nevertheless, all that is very interesting. And I think that all the studies that Avi Loeb and Amir Siraj have done suggest that all the modelling that they've done suggests that the accelerations and the kind of heating that you get from atmospheric friction, that these microbes could survive all those things. And they also calculate that over the lifetime of the Earth, they say between 1 and 10 comets and between 1 and 50 interstellar objects have come close enough to graze the atmosphere. So it has happened. Whether they collected microbes or not is a different story.
As long as they paid their fare, I would imagine they got where they were going. I would take the argument a bit further and say it's probably both. We are seeding. Exactly. We are seeding other areas potentially, and other places are seeding us. Or
It could well be. That's right. I have to say that the panspermia theory, which is what this is called, the idea that life came to Earth from elsewhere, is still not really regarded as mainstream science, although the paper last year had some very, very compelling arguments in it, some really good articles online about it. Just essentially Google Chandra Wickramasinghe and it'll take you straight to them.
It's definitely a good discussion point at the water cooler at Geek Central.
Yes, I'm sure that's right.
They have a head office in New York, apparently. But it's one that just gets your tongue wagging. It's just one of those things that we can't prove either way, but it had to happen somehow, and all we've got's theory.
That's right. But one thing we do know is we've had Oumuamua, the what you call the space doogie. That's right. And
you've got to get it out there. It's going to become a common name.
I think you've already done it, actually. Comet Borisov, the one that's still in the solar system. These are two objects that have come from other solar systems and are just whizzing through. So we know those events happen. Really, the seeds are being laid, if I can put it that way, for perhaps a revolution in our understanding of where life came from.
We'll crack it one day, I'm sure.
We'll crack it, yes. Here on Space Nuts.
Indeed.
Nuts are always meant to be cracked.
Yes, well, that's their job. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
Of course, as always, I'd like to shout out to our patrons and thank you for your support of the Space Nuts podcast. Thank you for throwing a few dollars our way. It is well spent. I feed my goldfish with most of it, but whatever. Thank you so much for supporting us, and as a reward, we are adding bonus content to our Patreon page, patreon.com/spacenuts, so you can get some bonus material there. We also publish the commercial-free version of the Space Nuts podcast on our Patreon page. So if you'd like to join us on Patreon, patreon.com/spacenuts. And if you'd like to get down and dirty with other members of the Space Nuts community, you can do that through the Facebook group, Space Nuts Podcast Group on Facebook. A lot of people have joined up and they talk to each other and they ask each other questions, and some of them even answer each other's questions. Some people answer their own. It's a great little group, and it's good fun. And by the way, Fred told us about those clouds he took a photo of while he was up in the Arctic. I've put a couple of those photos on our Facebook page if you'd like to have a look at them. They are magnificent pictures, Fred. Those colourful clouds are beautiful.
Thank you very much. Yeah, I think I've got a feeling the ones that you've got are just the ones I took on my iPhone rather than using the camera.
Maybe, but they came out well.
Yeah, they did. They look good.
Yeah, he did it while he was driving too. Now, to some questions. And this one comes from Ashley Anderson. Hi, guys. I thought I'd try and respond to your request for more questions. Oh, did we? Anyway, the question I have is, what is the remnant of a Type 1a supernova? As the listeners are probably aware, a white dwarf star is a binary system, can accrete matter from the companion star unit it reaches to the Chandrasekhar limit, causing a supernova. What is left after the explosion? Not much. If the star is in the binary system, is a neutron star and accretes matter in a similar way, what happens to the falling matter, and what happens when the neutron star reaches the next critical mass of neutron quark degeneracy? Thanks, guys, and I hope to have some more questions for you soon. No, please don't. No, but he'd really like to hear Fred's thoughts on that. He also wants to hear how you became an astronomer. Well, we did actually do a segment on that.
Indeed, we did it because
ago.
Yeah, and he says, I really liked hearing Fred's description of how he became an astronomer.
There he goes. Yeah, I should read properly. But let's get on to the Type 1a supernova.
So what happens with these supernovae, these explosions, exactly as Ashley says. You've got a white dwarf star in a binary system with a normal star. The white dwarf has extreme gravity because it's only, the size of a planet, but has the mass of a star in it. So it pulls material off the companion star until it reaches, exactly as Ashley says, the Chandrasekhar limit, which is a limit beyond which it can't exist as a white dwarf. And I think, if I remember rightly, it's 1.4 solar masses. So 1.4 times the mass of the sun for a white dwarf means that it no longer can be a white dwarf, and it actually explodes. And it turns out, to answer the question, that it explodes completely. It doesn't leave a stellar remnant. It leaves an expanding cloud of gas, the supernova remnant itself, which is highly energized because of all the energy that's gone into it from the explosion. But there's no neutron star remnant. There is nothing at the center.
So when I said not much jokingly, I was right.
You were absolutely on the money. Not much, except there is a big cloud of gas. But, there isn't a football at the middle that you could kick around or anything like that. The cloud of gas. And they are actually carbon-rich and oxygen-rich, which I think comes from the fact that the white dwarf itself is rich in those chemical elements. And of course, this is how heavy elements are dumped throughout the interstellar medium, because of these expanding supernova remnants. The other part of Ashley's question is also likewise a good one. Supposing it was a neutron star that was accreting matter in a similar way. Now, I don't know whether this is physically possible, but it may well be that it is. What happens to the infalling matter? Well, it will be somehow absorbed by the neutron star. There will be a critical mass beyond which the neutron star couldn't stay a neutron star. It will collapse, in fact, to a black hole. And Ashley's mentioned neutron degeneracy. That's a state of matter when only the neutrons provide the outward pressure to stop something collapsing to a black hole.
No, it's when you find a group of neutron stars hiding in an alley doing drug deals. That's what degeneracy is.
So what do you make of electron degeneracy then? Because that's the situation.
That's the other gang. They're just as bad.
That's what happens in a white dwarf. A white dwarf star is electron degenerate. It's the only thing that stops it collapsing to a neutron star is the outward pressure of the electrons.
Okay.
Yeah. It's all in Cosmic Chronicles, Andrew. You should
I know it is. I've got to download my copy. It is. Is it available as an ebook?
It is. Yeah, absolutely.
Well, that's the easy way.
I have it on my phone in case I want to read it.
Yes. That's the funny thing. I don't know about you, but I don't read my own books very often.
Well, no, you kind of know what's coming next.
I read the darn thing. I've read it over and over again. But once they're published, you tend to not do that.
No,
It's a weird science, authoring. Oh, by the way, my new book,
yes,
what of which still doesn't have a title, is just about finished. I finished the final chapter today, actually.
Oh, well done.
Waiting for the rain. And hang on. Well, I was supposed to check, wasn't I?
Well,
Well, it's definitely darker. There's no sunshine out there. So, but
it's coming.
No droplets. No droplets as yet. But yeah, I just got to write the epilogue because I love to write an epilogue. And then it's done. And then I've got to get it proofread and typeset, and, probably in a decade or so it'll be ready. But yeah, I'm devoid of ideas for a title. I can't really come up with something. So I might, when the time is right, throw it to the audience and see if somebody comes up with a title idea for me. We'll see how we go. That's for another episode. Right now, we've got to get on. Oh, thanks, Ash, for your question. Next question is from William Torres. Greetings from Pacifica, California. I have a question regarding Hawking's radiation. I assume that the Hawking radiation theory presumes that when virtual pairs of particles are created near this event horizon, that the number of antiparticles falling into a black hole outnumber the normal particles, hence causing the black hole to evaporate. If so, why is it the case that the ratio is not a random 50-50? I'll be waiting to hear your answer. I'm just making him wait. Thanks for your Space Nuts podcast. I've been hooked on it for the last 3 years or so. William Torres. Get a life, William. No, seriously, thank you for your support. That's wonderful. Good question. It's one of those sort of complicated ones.
It is. And I've basically got the piece of text that I was looking for earlier on today in front of me. I think the first thing to recognize is that this is a quantum process, and so normal logic doesn't necessarily apply. But William is right in that the fluctuations in the vacuum cause these particle-antiparticle pairs to appear. But I think which of them falls back into the black hole is not limited to being just the antiparticles. I think it's random. So you have one of the pair falls into the black hole, the other one escapes.
I think it would be fair to say that black holes are not fussy eaters.
Oh, that's absolutely true. They just digest everything that's going past, anti or not. If you've got, if you're an observer, an outside observer looking at the black hole, in order that the total energy of what you're seeing is preserved, the particle that got eaten by the black hole has to have had a negative energy. So this is where all these weird arguments come in. And so if it's got a negative energy, that means the black hole has lost mass. And to an outside observer, an equivalent scenario is that the black hole has basically just emitted a particle. So it sounds like gobbledygook, but it is not a random phenomenon. The fact that one of the particles is absorbed by the black hole, the fact that gives it a negative energy is not at all intuitive. It comes about just because of the relativistic and quantum effects that surround this process. I mean, Stephen Hawking was probably much better at explaining it than I am, but that's the best I can do at the moment. There is actually, I would refer anybody interested in this. Let me just go back to another web page. There is a really good Wikipedia entry on Hawking radiation, and it gives you everything from the kind of broad descriptive view to the equations themselves, which are a little bit fearsome. But it is all there, and is worth a look if you're interested in the process.
Very good, and thank you for your question, William. Appreciate it, and Ash as well, and everybody else who's sent us in questions. We've got a few to get through. We'll get to them, and we will also be adding some more information to our Patreon account, some bonus material there if you would like to subscribe via patreon.com/spacenuts. We'll just keep adding to the material on Patreon. And a reminder too, if you would like to visit the Space Nuts shop, it's at bytes.com/spacenuts, BITESZ.com/spacenuts. Cosmic Chronicles is there, as well as some T-shirts. I'm thinking we need to get mugs and caps and stickers. Who knows, Fred? We'll keep working on it. But yeah,
I had a look at the T-shirts. They look great.
They look nice, don't they?
Yeah. We should get one, shouldn't we?
I got my son one for his birthday. But I haven't. I'm sort of pushing Hugh to get polo shirts, as you can plainly see. I love polo shirts.
Yeah, that's right. Polo shirts.
I would love a polo shirt version of the Space Nuts logo, right there over my heart.
There you go.
Anyway, thank you for listening. Thank you, Fred, as always. It's lots of fun. That's all I was going to say. It's lots of fun. I shouldn't have stopped on an up inflection.
That's all right. You're Australian.
Yes,
and Australians all do that.
They do, don't they?
Yeah.
Thank you, Fred. We'll catch you next week.
Sounds great. See you later.
Fred Watson, Astronomer-at-Large. He's a professor, you know, and we will be back next week with yet another edition of the Space Nuts Podcast.
Space Nuts. You've been listening to the Space Nuts Podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.